Alright, so I've got a few Mailbag items here. This thing here weighs a ton, I already know what that is. And a couple of items. Interesting, this is item 2 of 2. Right now, this is again from that auction score where all these things are fairly cheap online. And so I purchased a whole bunch of stuff you would have already seen. And it's 2 of 2, so I'm thinking, what happened to 1 of 2? Because I haven't seen 1 of 2. So I'm going to have to make sure that everything actually turns up, because it might have gone missing. We'll see what happens. Anyway, so have a look at this. Pro tip, when you're cutting tops of boxes, do that. So you don't cut through what is inside the box. Dave might do that occasionally in his videos. Right. Oh, awesome. I was waiting for this. This is brilliant. That was pretty quick delivery. Now these are punch downs Ethernet or RJ45 terminals, commonly used for Ethernet connections. Alright, so here we go, like this. And this one here. So it's a 4-way terminal block. So I can run 4 Ethernet cables into the same housing, into the same wall cavity. I mean, of course, my house being flooded, and in fact it's been ripped apart right now. It's unlivable. In case you haven't noticed. If you didn't know about that, then look at my video from 5th of January this year. You'll see what happened. Anyway, so all the walls are currently ripped off. Oh, yeah, not pull on that wire. And so I've got the opportunity to run Ethernet cables in the walls and put some extra jacks in like that. So I'm going to run 4 cables. I've already got one run to the garage here where I am right now working, and that gives me 3 other spare ones. One's going to go to the living room for the TV and everything like that. I'll probably put a little hub there as well, a little switch. Gives me 2 spares, which I think I'll probably I may go to one of the bedrooms with that. So, and then maybe a partition wall so that I can run it through either side of the wall to either bedroom, things like that maybe. So I'm not sure yet, but I thought, well, I'll get a 4-way, and then I've always got expansion opportunities, and that's what I like to do, you know. So that's great. So I wanted that. That was fairly cheap. That was from another auction site. It's quite ironic, really. I'm buying things from an auction site, and I own an auction site. I own and run my own auction site, which I built all the code for it years ago, over 10 years ago, and things still sitting there running quite happily. Don't have to do anything with it. It just runs over by itself, looks after itself because it's all automated. I managed to write lots of code to automate everything and looks after itself. I don't have to do much. Anyway, fortunately it's not grown as I'd like it to have done. Anyway, I'm digressing. So here's another thing here from RS. It's probably capacitors, but it might not be. Look at this. What does this say it is? Okay. These are for my little project I'm working on right now. I'm undecided exactly how I'm going to do it yet, so I'm getting all different kinds of parts and allowing for every option for how I finally do it. Now what it's about is I'm building I intend to build a capacitor leakage tester. Alright, now it's a fairly simple principle. You shove a high voltage through a load, or through a capacitor, or attach a capacitor to high voltage, or wherever the voltage is suitable for that capacitor. So it's a 400 volt cap, and chuck 400 volts on it in theory, and still have it survive without blowing up in your face. But you measure the current going to the capacitor, and then based on that current measurement, you can determine whether the current's got leakage or not. Okay, so you can do high voltage capacitors and check for leakage. A normal capacitor tester can't do that, so it's like an extra level of testing. So if you've got a capacitor which tests okay with a cat tester, you think, well, it's probably okay, but you're not quite sure, then you can do this other test and check the cap, make sure it looks okay that way. So instead of maybe having to spend $20 on a single high voltage cap, you may not need to do that, because it's actually nothing wrong with it. But anyway, these parts here for that is options. Now these are what? Can't bloody read it. Gets a bit of light in here. TL7830, and that is was it TL783? Was that C? Might be C. This is a voltage regulator. Now you think, okay, right, used to like LM317s, that sort of thing. Well, this does 1.25 volts up to 125 volts. Alright, so obviously it's adjustable, but that's the range you can work on, which that's got some good possibilities there if I have like a low voltage range and a high voltage range. Maybe to potentially prevent accidents from actually being on the wrong range. So those can go up to 125 volts. Alright, so that's one option I've got. I'm not likely to use this one because I've got another idea in mind. And these ones here, I call them to a piece of paper. These are LR8N3, which are also voltage regulators. But believe it or not, these little things here, they can only do 10 milliamps, right? So not like huge voltage or anything, huge currents, but 10 milliamps is probably going to be sufficient. These do 440 volts, right? So these do 1.2 volts to 440 volts. Right? Little TR92 package, incredible. So that's more likely what I'm looking at doing. All right. Another alternative, which is also looking probable, right, is to actually just use a resistor divider, which is how it's done in a lot of the old Heathkit stuff like that. So he's using high wattage resistors in a series chain, and when you tap off from each point, you get a fixed voltage. Nice, simple principle. You know, nothing really to go wrong. But I was trying different ideas and different prospects of what I could potentially do for those. So, you know, I may not even use them for this. I may use them for something else. Right. Let's see what this is. Well, I know what this is, but you don't know what this is. I like the way they packaged it, so the handle comes out the top so they can carry it. That's quite a good idea. Well done. It's a little bit dirty. It's a lot dirty, but okay. Let's try and get out of the box. Well, it has a current test tag, which is awesome. That's nice. How did it pass on the current test tag without the correct legal pins? Huh? Really? Naughty, naughty. This is Turner's Auctions, right? Now, I have a little bit of understanding about electrical stuff. Yeah. I'm not an electrician, but I know a bit about it. And I know that New Zealand plugs, now, the legal requirement is that these pins must have a plastic sheath down them. So you cannot touch those pins when you plug them in and out, right? Also, this is all really dirty, and I've scraped them up a little bit to try and clean them, but not very well. So, this plug isn't legal. And yet it's got a current test tag on it saying it's fine. That's not very good. You know, because it's still got this corrosion on there. Well, not corrosion, it's just oxidization. But yeah, I know that these kinds of plugs are no longer legal. If it's got a test tag on it, this has to be upgraded to the current standard, and they haven't done that. So that's a bit naughty. If anyone happens to know anyone that works at Turner's Auctions in New Zealand, I want to let them know about that. That's not right. Okay, what this is, I might even email himself, just point out to him, but anyway. This is an isolation transformer. It sounds like it's got something rattling around in there. It does, it has something rattling around inside the bottom of it. So, Great, but it's an isolation transformer. What's it going to do? 100 VA, sorry, 1000 VA. Right, so 1-to-1 ratio. So it's just for isolation. Now, my bench, I have to be kind of mindful when I'm using mains gear on my bench, because I'm using an RCD supply. Well, everything comes from an RCD, right? And then I've got a UPS which is running all my bench equipment, which means that because it's going through the UPS, it may not necessarily cause a mains RCD to trip. So I have to be careful about that aspect, because it acts like an isolator. You know, it might not trip. I haven't tried. I probably should try. Actually, I do actually have a tester. That's the point. I do have a tester. I can try that, and let's see what happens. And I'll do a earth leakage test. I should try that. Make a good video. Anyway, so I've got this isolation transformer. This was cheap. The last one I looked at isolation transformers, I was looking at around $300. I paid, I think it was about $50 for this. And I'm assuming, of course, that it's actually okay. Based on this, who knows? So it's $50 off, 51 or something like it was. I think it wasn't much for the actual transformer. I think it's about $40 postage. So I paid almost as much in postage as I did for the unit, but that's not uncommon for me when I'm buying stuff a lot from the US for test gear. You know, which I buy from eBay and all that. I might pay $100 for the test gear, and I might pay $200 postage. That's not uncommon. So yeah. So I've got a little isolation transformer now, so I can hook this up on my bench as well, and on any test gear I'm doing on the bench, which I'm working on, I can then run it through the isolation transformer. Because currently what I've got is in this particular setup, I've got the bench test gear, or the bench items I'm repairing, going straight to the mains. It's not going through the UPS, so it's isolated from all the bench gear in that way. So if it does have a fault, it should trip the RCD. I've got it going that way, but there's still potential there for me to get a zap off it. So I'd rather actually use an isolation transformer and run it through this, and so I'm not a earth leakage path for this thing. That's the plan. Okay, I think that's it for now. So I thought I'd just open the top of this up, because it's got like 4 screws which hold the top on. This is what's inside it. So that's what's floating around, is a piece of ceramic from this fuse holder here. So it has a built-in fuse, which has multiple strands of fuse wire on it. How many strands are in there? So 3 strands there. Yeah, there's 3 strands of fuse wire in there. Okay, this is like, come on guys, this is just a joke. This is supposed to be an electrical safety test. Illegal plug. Illegal fusing. What the fuck? Come on. That's worth an email, I think. So, I've emailed Turner's Auctions and gave them shit about the person that did the pat test tag on this thing, because the person that did this doesn't seem to know the regulations as well as I know them, and I'm not even an electrician. So, although I do have ESTA, but anyway, that was years ago. Now see, here is 3 strands of fuse wire, and they actually look like they've got hot too. It could just be a little bit corrosion, but there's 3 strands in there. Alright, see that? Get the light on it right. Maybe you'll see it. Okay. 3 strands here. 1, 2, 3. So, and these, I've got my fuse wire out. I've had this stuff for years. I almost never use it. Now, bear in mind, this is a portable appliance. It's a plug-in unit. Now, our power points in this country are rated at 10 amps max. So it's a 10 amp system. This has got a 100 VA rating. So that's what, around 4 amps or so roughly, you know, give or take a bit. So this fuse wire here looks very similar to 5 amp fuse wire. So this looks like 15 amps on a 10 amp circuit. How's that pass a pat test? Here's some 10 amp fuse wire right here, which is what I'm going to put back in it, which is what it's supposed to have. And that's what I'll be putting in, if I can untangle it. As always, it's tangled up. Anyway, I'll sort that out afterwards. But that's what I'm going to put back in. I don't have any circuit breakers to replace this with right now. I might actually get one and replace it with a circuit breaker. But right now I want to put the correct fusing in it, and then I'll do some tests on it to actually see how safe it really is. Seeing as whoever did this pat test tag didn't actually understand what the hell they were doing. Okay, so there you go. That's the correct fuse wire installed. And we shall do some basic checks. This is get my old Digitech out. And let's do a couple of basic checks on it. I mean, there's no earth connection on the casing, but that's alright. I mean, it's isolation transformer. It has an earth pin on the plug, but there's nothing on the, there's no earth tag on the casing anywhere to actually attach an earth. So yeah, it's probably fine. Let's just do some basic resistance check, shall we? See what we get. So I've got 0.3 ohms there. And just check this way, shall we? Pull this cover off, check the end of the wires. I've already had this cover off once and had it all look in there. Looks kind of okay. Right. Yeah, alright. Yeah, okay. Well, those parts look alright anyway. Let's check across the terminals, across the actual winding. That seems fine. But I'm getting bad connections from these plugs, which are oxidised. 1 ohm across the line. Okay. So I'll check the output winding side. Let's see what that looks like. It's about 1.2 ohms or so, 1.1 ohms. These are probably slightly dirty, but it's not much you can do about it. Might have to try and get in there a bit cleaner or something. Now there is an earth pin, but there should be no earth connection. That's right, there isn't. That's fine. So yeah, I'll plug that in, I suppose, and it should be fine. I think I might do it. I've got a installation resistance tester in my drawer without any batteries in it, because I rarely use it. But I might get that out and just check the insulation breakdown and things like that, just to make sure that there's isolation within the transformer looks okay from side to side. I can't do that with that meter, it's not no voltage on it, so I need to do a high voltage test one side to the other to make sure there's no direct pass through, which is probably the person who did this tag didn't even consider doing. Okay, so I've got my Sanwa insulation resistance tester out, so let's just do some checks on this. Battery check. Yep, cool. Should be. It's got a brand new battery in it. And let's do a resistance check on that. 500 volts is what I want. That's fine. So let's see how we go between one of them, and we'll go to casing first. Yep, that's fine. The other side, casing. Yep, that's fine. So we'll check on the output connections. Nothing there. Nothing there. Check the other side as well. Nothing there. Nothing there. Also I want to check from the casing to the other side, so I need an earth point, which that probably is. I'll find out. Yep. So check there as well. Nothing. And nothing. Okay. Insulation resistance looks fine. That's not an issue. But I doubt the guy checked that.